Good day, viewers. Welcome to today's class. Today we're looking at WAEC Physics past question. So let's dive right into it. Question number 1 says, the inner diameter of a test tube can be measured accurately using a dash. Now, for you to measure the inner diameter of a test tube, you need an instrument that has jaws. And the only instrument that has jaws that can measure the inner diameter of a test tube is the vernier caliper. So the correct answer to this question is a pair of vernier caliper, which is option D. So that takes us to question number 2, which says two bodies have masses in the ratio of 3:1. They experience forces which impart to them acceleration in the ratio of 2:9 respectively. Find the ratio of the forces the masses experience. So in this question, they already told us that the masses M1 ratio M2 is 3:1. That is to say that let's say M1 is equals to M, which means that my M2 will be equals to, if M1 is equals to 3M, it means that my M2 will be equals to M. So this is M1 and this will be equals to M. With that same phenomenon, they say that their ratio of their acceleration, it means that my A1 here is going to give me the ratio of the acceleration is 2A and my A2 is 9A. Then it said find the ratio of their forces. We know that, so we are looking for F1 ratio F2. We do not know, but we know that F is equals to MA. That is the same thing as saying that F1 over F2 is equals to M1A1 over M2A2. This is the same thing as saying that I have my F1 over F2 is equal to my M1 is 3M times my A1 is 2A divided by my M2 is M times my A2 is 9A. So M cancel out M, A will cancel out A. 3 here 1, 3 here 3. It means my F1 over F2 is 2 over 3, which is the same as saying F1 ratio F2 is 2:3. So the correct answer to this question is 2:3, which is option C. So that takes us to question number 3, which says particle of mass 10 raised to the power minus 2 kilograms. So the mass was given as 10 raised to the power minus 2 kilogram is fixed to the tip of a fan blade which rotates with angular velocity of 100 rad per second. So our omega was given as 100 rad per second. Then it said if the radius of the blade is 0.2, if our radius is 0.2 meters, what is the centripetal force? So we are looking for the centripetal force. We do not know. And we know that centripetal force is given as m omega square r. M omega square r. So this is the same as saying that my centripetal force is equals to 10 raised to the power minus 2 times 100 square times 0.2. This is the same as saying that I have my 10 raised to the power minus 2 is the same as saying I have 1 over 100. That will give me times 100 times 100 times 0.2. So 100 there will cancel out 100, and that will give me 100 times 0.2 will give me 20 Newton. So in this question, this means that the centripetal force in this question is 20 Newton. So that takes us to question number 4, which says a lead bullet of mass 0.05 kg is fired with a velocity of 200 meters per second. So we have our lead bullet, the mass M1 as 0.05 kilogram, is fired with a velocity U1 as 200 meters per second into a lead block of mass. So our M2 is 0.95 kg Given that the lead block can move freely, the final kinetic energy after impact is, so our Ke is unknown. Remember that the lead block was stationary, so its initial velocity u2 is supposed to be 0 meter per second. So the first we are going to do is to find their common velocity, because for the lead block to move freely, it means that the bullet causes both the bullet inside the lead block and the lead block itself to move. So this means that I will tell them that my momentum before collision must be equal to what? Momentum after collision. So momentum before collision must be equal to momentum after collision. This means that I have m1 u1 plus m2 u2 must be equal to v open bracket m1 plus m2. And this, we're using this formula so that we can find the common velocity. So this means that I have 0.05 times 200 plus 0.95 times 0 is equal to v open bracket 0.05 plus 0.95. So that means that at the end of the day, what you're going to be having is 5 over 100 times 200 plus 0 is equal to v open bracket 1. So this 2 0 cancel out 2 0 from here. It means I have 10 is equal to v. So my v therefore is equal to 10 meter per second. So this is the final velocity with which they move, but that is not the answer to the question, because the question asks us to find the word kinetic energy. So for us to find the kinetic energy, we have to apply the formula for kinetic energy, which says that Ke is equal to half mv squared. So this is the same as in I have 1 over 2 times my mass here will become 1. That's the summation of the two masses. This is times my velocity is what? 10 squared. So this is the same as in I have 1 over 2 times 100, and that will give me 50 joules. So it means that the correct answer to this question is 50 joules, which is option A. So that takes us to question number 5, which says a ball of mass 0.1 kg. So we have our mass as 0.1 kg is thrown vertically upward with a speed. So we have a velocity of 10 meters per second from the top of a tower 10 meters high. So we have a height of 10 meters. Neglecting air resistance, its total energy just before hitting the ground is unknown. So we are looking for its total energy. Total energy is unknown. And my total energy is supposed to give me my Ke plus my Pe. So it means that the total energy here is supposed to be the summation of my kinetic energy and my potential energy. And in the question, they gave us our G as 10 meters per second squared. So the first thing we're supposed to do is to find out the Ke, and then we also find the Pe, and then sum everything together to get our total energy. So we know that if my total energy is Ke plus Pe, this means that my total energy, it means that my energy is equal to half mv squared plus mgh. So this will give me 1 over 2 times, the mass here is 0.1 times, my v here is 10 squared plus 0.1 times 10 times the height, which is also what? 10. So this means that I have 1 over 2 times 0.1 times 100 plus, this will give me 10 when I multiply all of this together. So this is the same as saying I have 2 here 1, 2 here 50. 0.1 times 50 will give me 5. So I have 5 plus 10. That will give me 15 joules. It means that the total energy in this question is 15 joules, and that is option C. That's what? 15 joules. So that takes us to question number 6, which says a car of mass 800 kg attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is dash. So we have to find the power developed in the engine. So the first thing we do is to bring out our parameters. So looking at this question, they gave us the mass of the car at 800 kg. So our mass is 800 kg, and the speed or velocity of the car was given as 25 meters per second. The time it takes the car to attain that speed was 20 seconds, and we have to find the power. So we know that for us to find the power, we have to know what the energy is, because power is equal to what? Energy over time. This is the same thing as saying that power is equal to half mv squared over time, which means that my power is equal to 1 over 2 times the mass there is 800 times the velocity there is 25 squared divided by the time, which is 20. So if we simplify this further, this is the same thing as saying that I have 20 here will cancel. So I have, it means that my power is equal to 20 times 25 times 25. So, and that will give me, so that will give me 20 times 20 times 25 times 25 will give me 20 times 25 times 25. That will give me 12500 watts. This can also be written in index form as 1.25 times 10 raised to power 4 watts. So the correct answer to this question is 1.25 times 10 raised to power 4 watts, which is the same thing as what? Option A. So that takes us to question number 7, which says when the brakes in a car are applied, the frictional force on the tire is dash. A is a disadvantage because it is in the direction of the motion of the car. That is wrong. The frictional force is not a disadvantage when the brakes are applied. B says the frictional force is a disadvantage because it is in the opposite direction of the motion of the car. This is also wrong because it is not a disadvantage, but it is in opposite direction. That aspect is correct, but it is not a disadvantage. C says it is an advantage because it is in the direction of the motion of the car. Wrong. It is an advantage, but it is not in the direction of the motion of the car. And this says it is an advantage because it is in opposite direction to the motion of the car, which is the correct answer. It is an advantage and it is in opposite direction to the motion of the car, which is option D. So that takes us to question number 8, which says if the stress on a wire is this 10 raised to power 7 or 107? Okay, that takes us to question number 8, which says if the stress on a wire is 10 raised to power 7 Newton per meter squared. So we have the stress, we have been given the stress as 10 raised to power 7 Newton per meter squared. They said, and the wire is stretched from its original length. So our original length was given as 10 centimeters to a new length. So our L1 was given, our L2 was also given as 10.05 centimeters. Then it said the Young modulus of the wire is that. So we have to find the Young modulus. So for us to find the Young modulus, we have to know the strain of the wire. And we know that strain is extension over original length. Extension over original length. So if my strain is extension over original length, then I have to find out what the extension is. The extension here is L1 minus L0, which is the same thing as saying that I have 10.05 minus 10, and that will give me 0.05 centimeters. So I'll use this to find out what my strain is. It means that my strain is 0.05 divided by 10. So if I have 0.05 divided by 10, that will give me 0.005 which is the same as saying 5 times 10 raised to the power minus 3. Strain does not have a unit because extension is measured in centimeters or meters, and original length is also measured in centimeters or meters. So my Young modulus is stress over strain. This means that my Young modulus, therefore, is 10 raised to the power 7 divided by 5 times 10 raised to the power minus 3. So this is the same as saying I have 1 over 5 times 10 raised to the power 7 over 10 raised to the power minus 3. So this will give me 0.2 times 10 raised to the power 7 minus 3. So that will give me 0.2 times 10 raised to the power 10, which is the same as saying I have 2 times 10 raised to the power 9 Newton per meter squared. So the correct answer to this question is 2 times 10 raised to the power 9 Newton per meter squared. So that takes us to question number 9, which says a solid weighs 10 Newton in air. So we have weight in air as 10 Newton and 6 Newton when fully immersed in water. So weight in water is 6 Newton and 7 Newton when fully immersed in liquid X. Weight in X, 7 Newton. And then we have to find the relative density of the liquid. We know that our relative density of the liquid is supposed to give us upthrust of X over upthrust of water. Upthrust in water and upthrust in air, in X. So this means that my relative density is the weight in air minus weight in X over weight in air minus weight in water. So that's the same as saying I have 10 minus 7 over 10 minus 6. And that will give me 3 over 4. It means that my relative density here is 3 over 4. And that is option C. So that takes us to question number 10, which says, when temperature of a liquid increases, its surface tension dash. So whenever one of the ways we reduce surface tension is by increasing temperature. So whenever the surface tension is to be reduced, you increase the temperature. So when the temperature increases, the surface tension reduces or decreases. So when the temperature of a liquid increases, its surface tension decreases. So the correct answer is option A. So that takes us to question number 11, which says a gas at a volume of V0. So we have our first volume. V1 here was given as V0. In a container at a pressure P0. So our P1 here was given as P0. Is compressed to 1/5 of its volume. So we have compressed it to a new volume V2 as 1/5. That is 1 over 5 V0. What will be its pressure if the magnitude of its original temperature T is constant? So you are telling us that temperature T is constant, which means we are looking for what P2 is unknown. So what they are just giving us here is a question based on Boyle's law. So and we know that from Boyle's law, our V1 P1 is equal to V2 P2. This means that what I have is V0 times P0 is equal to V0 over 5 times P2. So this is the same as saying that I have, if I cross multiply here, I will have 5 V0 P0 is equal to V0 P2. So I divide both sides by V0 divided by V0. This means that my P2 is equal to 5 P0. So the correct answer to this question is 5 P0, which is option D. So that takes us to question number 12. So question number 12 says, a piece of a substance of specific capacity 450 joules per kilogram per Kelvin. So we have the specific capacity of this particular substance. Please, that is not specific head capacity, is heat. Specific heat capacity is a typographical error. So we have our C in the question as 450 joules per kilogram per Kelvin. Force through a vertical distance of 20 meters. So the height was given as 20 meters from rest. From rest, which means that my U is what? 0 meter per second. Calculate the rise in temperature. So we are looking for change in temperature. We do not know. Of the substance on heating the ground when its energies are converted to heat. So they gave us G as 10 meter per second square. So what I simply asking you here is to what? Relate the energy in specific capacity to a regular energy formula. And we know that energy ordinarily, or quantity of heat, so my energy is also equal to quantity of heat. So my energy is supposed to be mgh, and my quantity of heat is supposed to be mc change in theta. So this means that mc change in theta is equal to mgh. So m will cancel out m. This means that my c change in theta is equal to gh, which means that my change in theta is going to give me gh over c. So with this in mind, we can then solve for our change or rise in temperature. So this means that my change in temperature is going to give me 10 times the height that was given was 20 divided by the specific capacity is 450. So I have 200 divided by 450. So that will give me 4 over 9, which is the same as saying I have 0.444 Kelvin. So the correct answer to this question is 4 over 9 degrees Celsius, which is option B. And that takes us to question number 13, which says, Roman figure 1. A liquid boils when its saturated vapor pressure is equal to the external pressure. Roman figure 2. Dissolved substances in pure water lead to increase in the boiling point. Roman figure 3 says, when the external pressure is increased, the boiling point increases. Roman figure 4 says, dissolved substances in pure water decreases the boiling point. So they are asking us, which combination of the above are peculiarities of the boiling point of a liquid? So looking at this, we know that whenever you dissolve substances in pure water, the boiling point increases. It does not reduce. And all of the other options, like the first one, that is the original definition of boiling point. Whenever the saturated vapor pressure equals the external pressure, then the substance tends to boil. That is what? Boiling point. Then the third one, if the external pressure is increased, automatically the boiling point will also what? Increase from the definition of boiling point. So the combinations that have the correct peculiarities are Roman figure 1, Roman figure 2, and Roman figure 3. And that is option A. Roman figure 1, Roman figure 2, and Roman figure 3. So that takes us to question number 14. We say the temperature gradient across a copper rod of thickness. So we have a copper rod. Of thickness, so we have the thickness of the copper rod as the thickness, you can call it D or you can call it L, as 0.02 meters. So they said maintain at 2 temperature junctions. So we have 2 temperature junctions of theta 1 as 20 degrees Celsius and theta 2 as 80 degrees Celsius, respectively, is dash. So we are looking for the temperature gradient, and your temperature gradient is change in temperature over depth or length, and in this case thickness, can call it thickness. So this means that what I have is theta 2 minus theta 1 over D or L. So that's the same as saying I have 80 minus 20. divided by 0.02, which will give me 60 divided by 0.02. So that will give me, so I have 60 divided by 0.02, and that will give me 3000. So that's 3000 Kelvin per meter. So the correct answer to this question is 3000 Kelvin per meter, which is the same thing as saying I have got 3 times 10 raised to power 3 Kelvin per meter, which is option B. So that takes us to question number 15, which says, calculate the mass of ice that would melt when 2 kg of copper. So we are given a question. So let's bring out the parameters from the question. So from the question, they said, calculate the mass of ice. So the first thing we are looking for here is mass of ice, which we do not know. That would melt when 2 kg of copper. So the mass of copper was given as 2 kg. Is quickly transferred from boiling water. So which means that the temperature of copper at that particular time is 100 degrees Celsius because it was in boiling water. So a block of ice without heat loss. They gave us the specific capacity of copper, C of copper, as 400 joules per kilogram per Kelvin. Then they gave us the latent heat of ice as 3.3 times 10 raised to power 5 joules per kilogram. So with this, we are asked to find the what? Mass of ice. So you tell them first that the heat loss must be equal to the heat gained. This means that the heat lost by the copper must be equal to the heat gained by the ice. So it means that here my copper has what? Specific capacity, which is what? MC change in theta must be equal to the heat gained by the ice here is latent heat, which is what? ML. So this means that here I'll be having mass of copper times specific capacity of copper times my change in temperature here will be temperature of the copper minus 0 because it was transferred to block, which was what? 0. And this will give me the mass of the ice times the latent heat of ice. So this means that I have 2 times 400 times 100 is equals to mass of ice times 3.3 times 10 raised to power 5. So if I multiply this will give me 80,000 is equal to 330,000 m of ice. So I'll divide both sides by 33,000 divided by 33,000. So if I divide by, it means that the mass of ice is going to give me 0.2424, which is the same as saying that I have the mass of ice to be 8/33 kg. So the correct answer to this question is 8/33 kg, which is option A. So that takes us to question number 16. Question number 16, which says, the equation of a wave traveling along the positive x direction is given by the equation. So this is the equation of the wave. We are given this equation that says that my y is equal to 0.25 times 10 raised to power minus 3 sine 500t minus 0.025x. They said define the angular frequency of the wave. Now this question just requires you to understand the equation of wave. The original equation of wave says that my y is equals to a sine omega t minus kx. So all you have to do here is equate. So we are looking for the word angular frequency. Now angular frequency here is omega. So what simply means is that my omega is equal to 500. Or you can simply say that omega t is equals to 500 t. T will cancel out t, which means that omega is 500. But then we are not stopping there, because we can put this in standard form, which is the same as saying that my omega is 5 times 10 raised to power 2 rad per second. So the correct answer is 5 times 10 raised to power 2 rad per second, and that is option C. That is also question number 17, which says, if a sound wave goes from a cold air region to a hot air region, its wavelength will dash. Now, know that there is a relationship between the wavelength of a wave and its velocity or its speed. So when wave, we know that velocity of a wave is equal to f lambda. So, and when wave move from a region of a cold region to a hot region, which means that an increase in temperature, there's usually an increase in the speed of the wave. So if an increase in temperature leads to an increase in the speed, and we know that the speed of a wave is directly proportional to the wavelength of a wave, and we know that frequency is constant in a wave irrespective of temperature. So this means that the wavelength is equal to V over F, which means that an increase in the velocity of the wave must also lead to an increase in the wavelength of the wave. As since this wave is moving from cold region to hot region, it means that there has been an increase in the velocity of the wave. So automatically there will also be an increase in the wavelength of the wave. So the correct answer to this question is A, which says what? The wavelength will increase. That is option A. So that takes us to question number 18, which says the lowest note emitted by a stretched string has a frequency of 40 Hz. So the fundamental frequency in this question is 40 Hz. So if my fundamental frequency is 40 Hz, they are asking how many overtones are there between 40 Hz and 180 Hz. So I have 40 Hz and I have what? 180 Hz. They're asking me how many overtones can I see in this. We know that overtones are usually in terms of the value that you multiply your fundamental frequencies with. So the first overtone is going to be giving us 2f0, which is what? Twice the fundamental frequency. The second overtone is what? 3f0. The third overtone is 4f0. The fourth overtone is 5f0. So they're asking us how many of these overtones am I going to be seeing between these 40 Hz and what? 180 Hz. So my first overtone here is going to give me 80 Hz. My third overtone here is going to give me 120 Hz. My third overtone here is going to give me 160 Hz. My fourth overtone here is going to be giving me 200 Hz. So, and 200 Hz, we don't have up to 200 Hz. We have maximum of 180 Hz. So between our 40 Hz, which is the fundamental frequency, and our 180 Hz, I have a total of 3 overtones. So the question they ask me is how many overtones can I see? And I can see what? 3 overtones, which is what? Option B. So that takes us to question number 19, which says a man stands 4 meters in front of a plane mirror. A man stands 4 meters in front of a plane mirror. A man stands 4 meters in front of a plane mirror. So the original distance of the man, or the object distance, let's say DO of the man, is 4 meters. Then said if the mirror is moved 1 meter towards the man, so the new DO, let's say this is DO1. So DO2, the mirror has been moved 1 meter towards the man, which means that the new distance is 4 minus 1, which will give me what? 3 meters. Then they're asking us, the distance between him and his new image is dash. The distance between him and his new image is that. They're not asking us the distance between the man and the mirror. Remember that what we are having here, our DO, is the distance between the man and the mirror. But they're asking us distance between the man and the mirror. So let's say this is the man. If this is the man, and this is our mirror, distance between this man and the mirror here is 3 meters. Then inside the mirror, remember that what we are having is a plane mirror, and a plane mirror does not reduce or increase the distance. So inside the mirror, the distance between the mirror and the image will also be what? 3 meters. So this is the image of the man inside the mirror. So what they are asking us is the distance between this man and the image, which is what? Combination of the distance between the man and the mirror and the distance between the mirror and the image. So it means that the distance between the man and the image is going to be what? 3 plus 3, which will give us 6 meters. So the distance between this man and his image is what? 6 meters, which is option C. So that takes us to question number 20, which says, the inside portion of part of a hollow metal sphere of diameter 20 centimeters is polished. The portion will therefore form a dash. Now, because we're talking about the inside of a hollow sphere, in this case, it means that that portion that we are talking about, which is the inside, is going to form what? A concave mirror. But we don't know the focal length of this particular concave mirror. But since they give us the diameter, we can easily calculate the what? The focal length. So how do we do that? We know that the diameter was given as 20 centimeters. And we know that radius is what? Diameter divided by 2, which means that my radius is 20 divided by 2, and that will give me 10 centimeters. But the question is asking to find the what? The radius. Instead, what? The focal length. And we know that focal length is equal to what? Radius divided by 2, which means that my focal length is 10 divided by 2, which will give me what? 5. Which means that this particular mirror that will be formed using this hollow sphere is going to be having what? A focal length of what? 5 centimeters, and it's going to be what? Concave. So the correct answer to this question is a concave mirror of focal length 5 centimeters, and that is option A. So we've come to the end of today's class. I believe you enjoyed this class. If you have any question, drop it in the comment section. Don't forget to subscribe and turn on your notification bell so that you'll be notified when we drop a new video.
Hi, I'm sure you enjoyed the video you've just watched. To see more of this kind of content across all examinations, including WAEC, JAMB, JUPEP, GACAO, NET, SAT, IELT, literally up to 100 exams, make sure you hit the subscribe button and check the channels for all of these videos and tutorials.